Alright, the next tool I want us to quickly look into is Geomorph. Geomorph is very interesting tool. Has been used by many researchers to digitize 3D image. It's an R package. So we are going to, if you don't have R, you have to install R package. Then you can now install Geomorph on your R. Now let's see how to work with Geomorph. I have already installed R package. You have to load the library after installation of Geomorph. So you have to install Geomorph using this install dot packages. Then you install. Then just then you run this. This could be run separately. Let's say we have ply 1 as the first 3D image. You read the ply. It will only read in ply, not in OBJ and not in STL. It reads only in ply. So we're going to do read ply 1 to read dot ply, the folder and the file name where it is. So we have a and001.ply. Then my file equal to digit.fist. The ply name you put it here. This is the name of the file you want to digitize now. This ply 1. So it is here. So we want 10 points, 10 landmarks. So if you have 20 landmarks, you put it here. You have 30. You have to specify the number of landmarks you want here before you start digitizing. It automatically save for you a copy for you as NTS file, but you can also write a CSV file by yourself. For example, I wrote here write the CSV file, my file, so save a copy for me as CSV file, so I can see the two later. Anyone I prefer I can use. So now let's see how to do this. We run this. Load your, so it's loaded. Then you run this. You can see it's giving me error here. Say error in read.ply file. Mesh ply file is not in ASCII format. Format is binary, so it's binary format. So I need to change now. I need to remove the binary format for this, and that's what I'm saying. So don't forget this. This is very important. It must be in ASCII. So you have to remove the binary for Geomorph. So let's quickly do that. Let's open this guy here in Mesh Lab. So this is it. Okay. This is the hand. You can see export. Let's export. Okay. Let's say okay. Save as ASCII. Okay. Yes. Operating. So here you can see it's binary now. You can see. So you have to uncheck this and save. When you save, then it means that it's no more in binary. Now you can now call it. So we have a new one now called ASCII as a new file. So this file should be able to read now, because now we have saved this file as ASCII, not as binary. So you can rerun again, run this line again, and see if there's any error. So you can see there's no error, which means this file is ready to work. It has loaded. All right. So you can maximize a little bit. You can enlarge a little bit. You can look at the hand here. Okay, see the hand. So let us now click on this. Want to digitize now. So this first, you want first load the mesh file. So we want to digitize now. Click on this and run. I'm using R Studio, so you can use R Studio. Any one of them is okay. So now it has changed now, because it has changed, because it's ready for digitization. It's ready to be digitized now. It has changed. You can see. Okay. But the problem here is that you have to be picking the point one by one and be accepting it here. So if you want to pick this now, for example, now before you digitize, you must know your landmarks. You want to digitize. For that, in terms, every hand has landmarks. You want to read more about landmarks, you can go to this guy, basic principle and trend in hand geometry and shape and hand shape biometries. So by this guy, by Miroslav Baka. So you can read the book, the material here. You can download the PDF here free. you can read. It's talking about hand geometry and hand biometry. So you can read it here. It gives you the landmarks, the hand landmarks. You can see the hand landmarks here. Okay, so you can measure this particular. You can want to measure the thumb, the distance of the thumb, the length of the thumb. You can measure. You can see here from here to here. So you know the landmarks. So it gives us the landmarks of all everything here. So you can measure. You can measure. So here you can see thumb length, index finger length, middle finger length, ring finger length, pinky length. So all these ones, they are measurements. So you can see the landmarks measurement here. So you can go through this paper to understand hand geometry. If you want to use hand, I'm not using hand, so I just want to show you how to look at the landmarks here. So I just want to show you so you can see from here. This all you can digitize. You can do this from here. This is the landmark here. Here is the landmark. Here is the landmark. Here is the landmark. So you can see distance from here to here. You can measure. You can measure distance from here to here. From here to here. From here to here. You can measure. 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 So you can see what you can measure here. So based on the landmarks you have here. So you can go through this material, and you can find your way around it and see if you want to use hand geometry. There are not many hand data set for 3D. It's very scarce. So, but if you have good, you can do. So now let's see how to digitize this now. So what you do is just that you right click on it. So when you right click on it, to digitize, it will ask you if you want to accept or not. You say yes. That's the first point. You pick at the second point. Let's say we have 10 points, which we set here. We have 10 points. So let's right click on this thumb, for example. Now this thumb, let's pick a point here now. You're asking us keep this lemma. I say yes. That means you just press Y, enter. So continue. So before that, let's minimize this. Let's adjust this. Okay. I want to be seeing the two together. Okay. All right. So let's see. Now it's asking the question now. Select here. So now select another one now. Let's pick another one from here. Okay. Let's pick from here. A point. Keep yes. Pick a point here. Keep yes. A point here. Keep yes. A point here. I say no. You see that one, I got to redo again. You can see. So that one is not accepted. I say no. So I want to do another one again. So I say no again. I don't want that. So I want to do again. No, I don't want. You can see now. That's why it's giving error, because sometimes no, I didn't get that. I didn't get that properly. So you can see. Okay, so now I can accept now. Yes. Okay. There's something wrong there just now. Okay, let's pick last point here. No. Okay, let's say we have 10 points now. We have picked 10 points. Don't mind the point I pick here. I'm just using it as a sample. Don't mind this point, so you can rotate. You can rotate. If you want to pick point from back, also you can rotate and pick from the back. Okay. I'm just giving you this as a sample. Don't mind the point I'm picking. Okay, so this is a little bit more flexible than the other ones we have done before. So now we have picked our point. So we have finished the point. So you want to say yes, keep this. So you can see this that we are done with point. So we can save a copy. Let's save a copy as let's save a copy. So we have a copy saved. Do a ready copy already been. Immediately you finish the 10th one, it will save a copy as a NTS file automatically in your document file or in your working directory. So, but you can also save a copy as CSV file. Let's see the output of the landmark data. You can close this. So you have many specimens. You have to load them one by one and digitize them one after the other. That is how you do in a Geomorph. So let's go to document. Okay, so we have the first one is ply one. This is the NTS file. If you open this is our landmark digitize. Okay, this is our NTS file. This NTS file. So let's also look at the CSV file. This is CSV file. You can see it's the same data we showed just now. Okay, let's go back and compare the two. No difference from the two. Okay. You can see 92. Okay. You can see so it's the same thing, right? So these are our files. We have digitized, so we can copy this out now. But you can see the problem, a little problem we have here is that now this file is supposed to be in the standard format, which means you need to align them now. Maybe this one should supposed to be here. This one supposed to be copy. This one supposed to be here. This one here. This one like that. So it's supposed to be that for one. But this is for the first specimen. It's supposed to be in one straight line now, and you put the specimen 1 here, for example. Then for specimen 2, we do the same thing. So all this one is for first specimen now. So if you have another specimen, we have to do the same thing for the second specimen and put them on straight line. So if you have a lot of specimen, you may not want to be copying and pasting. You may want to use maybe something like a Python to write a short program to automatically to generate them, to align them. So you may not want to be using copy and paste. So maybe we may look into that maybe next time, not under this course. Okay, so let's this is how to do in Geomorph actually. So we can next lecture we are going to look at how to do it better and using also sliding selling landmarks. So I'm going to use how to do that. We're going to now do a standard landmarking. Then we are going to keep that for our next part. Which is part for now here. So by the next segment, we will see how to do it better. Thank you so much for this section. Thank you.